Welcome to VTeach. In this section, we are going to discuss about the Zener diode. So, how the Zener diode is working, and as well as what is the avalanche breakdown, and as well as the Zener breakdown. The differences between the avalanche breakdown and Zener breakdown we are going to see in this session. So, first, the Zener diode, why we need to prefer. Generally, the Zener diode we are using in the breakdown region. Especially this diode is we are using in the breakdown region. So we can see the basic difference between the normal diode and Zener diode. Normal diode also it is having some breakdown, but that due to the large power dissipation, once the PN junction diode is affected, that breakdown, that is called as avalanche breakdown, again it will not reusable. If you are coming for the Zener breakdown, once the diode is affected by the Zener breakdown, again we can reuse, and as well as that Zener breakdown also we can use for the some different applications. Now, if you are coming for the Zener diode, the symbol of the Zener diode is look like as a normal diode only, but at the cathode side we need to mention that that is a Z. So only the basic difference between the PN junction diode and Zener diode is at cathode side. You can call this is anode, and here also this is also anode. This is the normal PN junction diode, and this is the Zener diode, and we are saying that this is the cathode. Here also it is a cathode, but the basic difference between the normal PN junction diode and Zener diode is at negative side it is indicating the Z indicating that it is a Zener. Now we can see that why we are not using the normal diode means a normal PN junction diode operating in breakdown region is very large. It is having the breakdown is very large. Due to the large power dissipation, the diode gets damaged. If you are using the normal diode, once if it is affected by the breakdown, then we can't reuse that diode because it is getting the damaged. If you are coming for the Zener breakdown, it is a more doped than the normal PN junction diode. The Zener diode is having the more doping. So due to that, we can change the Zener diode action. You can see here, you can see the characteristics of the Zener diode. See, the characteristics of the Zener diode is look like as a normal diode characteristics only. But here the normal diode, how it is having the after the breakdown, how the forward bias current is increasing, here also it will be increasing like this only. And if you are coming for the reverse Zener diode, reverse characteristics of the Zener diode, then the reverse characteristics of the Zener diode, it is having the breakdown. It is not like as a normal breakdown. The Zener diode always we are using in the reverse bias only. But normal diode, it will how the working in the forward bias. The Zener diode also working as well as it is working as the same condition, same characteristics. It will be give in Zener diode also. The characteristics of the normal diode forward bias characteristics and the forward bias characteristics of the Zener diode both are same. There is no change. If you are coming for the reverse bias, there is some changes is there. So the breakdown when it is happened in the Zener diode, that breakdown we are saying that it is a Zener breakdown. After affecting the Zener breakdown, again we can reuse that diode. If it is in the normal diode, we can't reuse that one. So you can see the symbol and as well as the characteristics. Next, Zener diode breakdown mechanism. So we will see that what is the breakdown mechanism, and we will see that what is the avalanche breakdown and as well as the Zener breakdown. If you are coming for the avalanche breakdown is affected due to the external voltage and it breaks the covalent bond to produce a new electron hole. So if the covalent bonds is there, if it is like this, the covalent bond between the two electrons, if you are taking the silicon material, so if it is the covalent bond, then due to the large temperature, this covalent bond breaks, meaning of that one, the electrons from here, it will be come out, and here some, so you can find out here, it is an electron, and here you can find out some hole. Okay, so due to the large temperature, the covalent bond is getting the breakdown, then the electron which is present in the covalent bond, that electron will be come out, and here another hole will be there. This is called as a electron hole pair. So external voltage applied and breaks the covalent bond to produce a new electron hole pair. Now we can call that this is a new electron hole pair. This new electron hole pairs in turn generates more electron hole pairs, because once if it is coming to the here, then it will try to fill the another hole, like that this recombination is going to be continue. So more electron pairs are bonds and the process continues. So this electron hole pair, the process is going to be continuously. If I am increasing the temperature like that, the number of the holes and electrons pair are going to be increase. So due to that, the process is it like as a chain process, it is increasing like as a multiplication. We can call that is a avalanche multiplication. You can see that this cumulative process is known as a avalanche multiplication. The electron pair hole process continuously, if it is going on, then we can say that it is a avalanche multiplication. Due to this, large current is seen at the terminals of the diode for small variation in the voltage. So after the breakdown, if you are increasing the little bit voltage also, then the large current you can see that. If you are coming for the Zener breakdown, in this mechanism, electron hole pairs are generated by applying strong electric field. It is depends upon the strong electric field. Because of the presence of strong electric field, direct repair of covalent bonds takes place. Due to this, new electron hole pairs are generated. The breakdown occurring due to the application of strong electric fields is known as a Zener breakdown. So the avalanche breakdown and Zener breakdown will be like as the same, but the multiplication is going to be happen in the avalanche breakdown, which is not possible in the Zener breakdown. Now we will see the differences, basic differences between the Zener breakdown and avalanche breakdown. The avalanche breakdown generally it will be happen in PN junction diode, and Zener breakdown it will be happen in Zener diode. Now we will see that what is the basic difference between the both diodes and breakdowns. Zener breakdown occurs at heavily doped PN junction diode. The basic difference between the normal diode and the Zener diode is doping. The Zener diode is having the more doping compared to the normal PN junction diode. You can see that at the avalanche breakdown, lightly doped PN junction. So in Zener breakdown, depletion layer is narrow. Compared to the normal diode, the Zener diode depletion layer is narrow. The reason why the depletion layer is the narrow means due to the more doping is in the Zener diode. So that's why the depletion layer is having very narrow in the Zener diode. For coming for the temperature coefficient in the Zener diode, it is a negative temperature coefficient. The meaning of the negative temperature coefficient means if the temperature is increases, the temperature is increases and the response it is going towards to the reverse. So if you are coming for the normal avalanche breakdown, if the temperature is increases, the response is going towards to be positive. Okay. In reverse bias avalanche breakdown, the breakdown is depends upon the temperature. If the temperature is increases, that breakdown voltage is going to be increased in the avalanche breakdown, which is a quite opposite in the Zener diode. If the temperature is increases, the breakdown is going to be decreased in Zener breakdown. The reverse bias voltage to breakdown, to happen the breakdown in the Zener diode, the reverse bias voltage is less than the 6 volts is enough. Okay, reverse bias voltage is greater than the 6 volts is required for the avalanche breakdown. And VI characteristics are sharp in Zener breakdown. VI characteristics are less sharper than the Zener diode. So, and as well as you can see that diode offers less resistance, diode offers high resistance. The PN junction diode is also having the resistance that already we discussed in the last sessions, that is a static resistance and dynamic resistance. In the PN junction diode, we are having some resistance compared to the Zener diode. This resistance is high. The Zener diode is having the less resistance. Again, the reason the Zener diode is having the less depletion layer. If the diode is having the less depletion layer, ultimately the resistance is less, which is having the more depletion layer, then that is having the high resistance. So as temperature increases, breakdown voltage decreases. As temperature increases, breakdown voltage increases. Next, high electric field is mainly responsible. The Zener diode in the Zener diode, the breakdown is happening due to the only one reason, that is responsible for repair of covalent bonds. If you are coming for the normal PN junction diode breakdown, that is the avalanche breakdown, the avalanche breakdown, the collision is happening between minority charge carriers, mainly electrons. But in the GNR breakdown, it is happening due to the responsible for the repute of covalent bonds. Pure covalent bonds, due to the covalent bonds, it is happening in the GNR diodes, and here the minority charge carriers collision, due to the minority charge carriers collision, it is happening in avalanche breakdown. Thank you.